In this video, I'm going to do a few more examples of absolute value inequalities. So I'm going to go through these four. So I suggest that you already are familiar with absolute value inequalities. I have lesson videos explaining all of that. And then if you were just interested in just seeing a few more examples, then this is the video for you. Okay, so let's just jump right into this then. So starting with the first one, so I've got the absolute value of 2x minus 4 plus 5 is greater than or equal to 7. Okay, so first things first, we've always got to have the absolute value isolated. So I'll go ahead and set this up first. And now that I have the absolute value on the left, which is one of the keys, so remember there are two keys with working with these. One is to always have the absolute value on the left side. And then the second is that the setup is dictated by which direction your inequality is going. So in this case, my inequality is a greater than. So I have really two ways to set these up. So for the greater than or greater than or equal, for the greater than or greater than or equal to, I always flip-flop that, I'm going to set up like this with an or. So let's go ahead and set this up. So this is going to be set up 2x minus 4 is greater than or equal to 2, or 2x minus 4 is less than or equal to negative 2. Okay, and now I solve both of these inequalities just separately. So this will be, let's see, if I divide both sides by 2, this will be x is greater than or equal to 3. And then for this one, so if I add 4 to both sides, I get 2x is less than or equal to, let's see, just 2. And then I divide both sides by 2, so I get x is less than or equal to 1. Okay, so here is my solution, but usually I need to also include the number line and interval notation, so we'll go ahead and set that up as well. So here's 1, here's 3. Okay, so where is x less than or equal to 1? That's going to go this direction with a big old square bracket. Square bracket means that 1 is included. And then where is x greater than or equal to 3? So that would be this direction, again with another big old square bracket. So that's the number line. And then for the interval notation, so I always read this like a book from left to right. So I start here. So this is negative infinity. And then I continue to 1. And then I pick back up at 3 and I continue on to positive infinity. And infinity is not a number, so it always gets a round bracket. Okay, cool. So let's keep going. Okay, so now I have 2 is greater than this absolute value inequality. So remember, one of the keys is to always have the absolute value on the left side. So the first thing that I want to do is I want to rewrite this. So I'm going to have 3 over 2. I'm actually going to rewrite this as 1/3 x. I just prefer to look at my fractions like that. And then, okay, I have 2, so I need to have the mouth of the inequality still eating the 2. Okay, so now we're all good to go. I've got the absolute value on the correct side. And now I see that this is a less than. So when I have less than or equal to or less than, I use the 3-part inequality setup. And we went through this in detail in the instruction video. Okay, so let's go ahead and set that up then. So I'm going to have 2 is less than, let's see, 3 over 2 minus 1/3 x is less than 2. Now, in this case, I would like to just get rid of the fractions and make my life easier. So the LCD between these two fractions is 6. So what I'm going to do is I'm going to multiply every single part of this problem by 6. And you have to multiply everything or you're going to change the value of the problem. So negative 2 times 6 is negative 12. When I multiply these together, so 2 goes into 6, let's see, 2 goes into 6 3 times. So I'm left with the calculation 3 times 3, so that's a 9. And then 3 goes into 6 twice, so I'm left with the calculation 1 times 2x, so that's just going to be 2x. And then this will be less than 12. And by the way, if you hear snoring in the background, my dog is napping away. She might even start dream barking if we're lucky, so sorry about that. Okay, so now let's keep going with this. And now I just go ahead and solve as usual, right? So now I need to subtract the 9 from all sides. So I'll go ahead and subtract the 9. So let's see, that's going to leave me with negative 21 less than 2x less than 3. Okay, and here's the other plot twist. So actually I'm going to make some more space for myself. Okay, so now I'm going to divide everything by negative 2, with the trick here being that when you divide by a negative number, the direction of your inequalities flip. So now this becomes 21 over 2 and 3 over 2, but notice how all my inequalities flipped. And so this is kind of awkward actually. So I want to change the order here. So I always like to have the smallest number first. So 3 over 2 is smaller than 21 over 2. So what I'm going to do is I'm going to do the same thing that I did earlier. So I just want to have the 3 parts of this. And then once again, the inequalities just eat the same thing. So this is going to eat x, and this is going to eat the 21 over 2. So now I have the x's between 3/2 and 21 over 2. So not beautiful numbers, but that's okay. We can deal with it. Okay, so I've got, here's 3 over 2. Here's 21 over 2. Okay, so this is really now x's between these two numbers. And then these numbers are not included because it's just less thans. So it's going to look like this. So there's my number line. And here's my interval notation. Okay, so this next one is actually a special case in disguise. So first things first, I need to subtract off the 5. And so I've got now 5, the absolute value of 5x plus 1 is less than negative 3. So the thing to keep in mind is absolute value is always greater than or equal to 0. So you want to now think about what does that mean in this case? This is saying that an absolute value has to be less than a negative number. When can that happen? Never, because absolute value is always greater than or equal to 0. So since this is never true, or we could say never happens, there is no solution to this. Okay, and so for my last one, this is also a special case. So first things first, I need to subtract off the 7. So now I have the absolute value of 3x plus 1 is greater than or equal to 0. And again, absolute value is always greater than or equal to 0. So here's an absolute value, and we want to know when is this greater than or equal to 0. This is true, right? This is always true. This is like the definition of absolute value. So this is always true, so I don't even have to go any farther with it. I can just say that this is all real numbers, so negative infinity to infinity. Okay, so that brings us to the end of this video. If you found that helpful, please consider hitting the like button. If you got more questions, you can always leave me a comment. Consider subscribing to the channel. I always appreciate it, and I will talk to you guys in the next video. Peace.